Hello students, welcome to Math Center Web Coaching. In our last video, we have seen what is orthogonal matrix, some properties of orthogonal matrix and examples depends upon the properties of the orthogonal matrix. Okay. Now in today's video, we are going to see what is unitary matrix, properties of unitary matrix and examples of the unitary matrix. Okay. Let's see the definition of unitary matrix. Okay. So let's start with the definition. A square matrix A is said to be unitary matrix if A into A theta is equal to I, which is equal to A theta into A. Means if this product of these two matrices, that is A, that is given matrix, and A raised to theta, means transpose of a complex conjugate. If the product of the given matrix and its transpose of a complex conjugate is equal to identity matrix, then the given matrix A is called as a unitary matrix. Okay. If this product will gives us identity matrix, okay, then the given matrix A is called unitary matrix. Okay. Now, when we are going to take the product, you can take the product A into A raised to theta or A raised to theta into A. Okay. In both the cases, our answer should be identity matrix. If the product of these two, A into A raised to theta, is identity matrix, then the given matrix is unitary matrix. So what is A raised to theta? Transpose of complex conjugate. Okay. So you can show A theta by A bar dash also or A bar T also, right? Now bar denotes complex conjugate, okay, and dash denotes transpose. Okay. Now let's move towards properties of the unitary matrix. If A is unitary, then A inverse is equal to A raised to theta. If A is unitary, then A inverse and A transpose are unitary. If A is unitary, then determinant of A, value of the determinant of given matrix, okay, is always equal to 1. If A and B are unitary, then A into B, the product of the given two unitary matrices, is always unitary. If A is skew Hermitian matrix, then the product of these two matrices, that is first is I minus A and second is inverse of I plus A, is a unitary matrix. Actually, these properties are so much important in exam point of view. If you are appearing for the competitive exams, okay, then they have asked some examples which are based on these properties. Okay, so let's see the example. Prove that the given matrix A is unitary and hence find A inverse. Okay, where A we have given here. Now, first part we need to prove that the given matrix is unitary, and in second part we are going to find out A inverse. Okay. Now for unitary matrix, by definition, the product of A and A raised to theta should be identity matrix. Okay, we are going to use this definition. So we need to first find out the product A and A theta, right? So A already we have. Now we need to find out A raised to theta, that is transpose of complex conjugate, this A theta. Okay. Now for A theta, we need to find out first transpose of the given matrix, right? So here I'm going to write the transpose of the given matrix here. 1 upon 2, this is constant as it is. Now transpose is nothing but interchanging rows and columns. So first row will become my first column. Second row will become my second column. And third row will become my, third row will become my third column, right? So this is the transpose, interchanging rows and columns, right? Now we need to find out bar. That means A raised to bar. That is nothing but the complex conjugate. Now for Z is equal to, suppose Z is equal to X plus IY is our complex number, then Z bar is nothing but X minus IY, right? So in this case, we need to change the sign of the imaginary part, right? This imaginary part. So here also we are going to find out, we are going to change the sign of the imaginary part, right? Okay. So let's start. This is 1 by 2 as it is. Now root 2 remains as it is. I into root 2. So I is the imaginary part. So we need to change the sign of this 0 as it is. Now here second row. In second row, here also minus sign. Okay. So minus sign, we need to change that sign. So I root 2 and minus root 2 as it is, because that is real, and 0, 0, 2 as it is. Okay. So we changed here sign of imaginary part. Okay. Now this is my a theta. Now we have a theta. Now let's take a product. So a into a theta, consider a raised to a into a raised to theta, which is equal to. So this is my a. What is my a theta? Just I'm going to write here. So this is root 2 minus I root 2 0 I into root 2 minus 2 0 0 0 2. Okay. I'll just this one. I into root 2. Okay. Now let's take a multiplication here. Okay. Or product of these two matrices. So 1 by 2 and 1 by 2 will become 1 by 4 here. And then next, now the product first row, first column, first row, second column, plus first row, third column will give us the first. Okay. So this is nothing but a raised to theta is equal to. So after solving this example, we will get 4 0 0 0 4 0 0 0 4. Okay. So next, I'm going to take 4 common from this matrix, and that 4 and this 4 1 upon 4 will get cancelled, and we'll get 1 0 0 0 1 0 0 0 1, and this is the identity matrix, right? So here, as you can see, that a into a theta, this product gives us identity matrix. Therefore our given matrix A is unitary matrix. Okay. And by definition of a unit, and by property of the unitary matrix, this property, first property. Okay. If A is unitary, then A inverse is always equal to A theta, right? So in this condition, our A inverse, because our A is unitary, our A inverse is nothing but A raised to theta. So what is our A raised to theta? We have find out this here, right? This term 1 upon 2 into this. So this is our A inverse. Okay. So what is that? 1 upon 2 into root 2 minus I into root 2 0 I into root 2 minus root 2 0 and 0 0 2, right? So this is our inverse. So that's it for this video of unitary matrix. I hope you like this video. If you like, please like, subscribe the channel and share it. Thank you.